Okay, so again, the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today, eventually, we're going to take a look at section 8.3. I'll take your questions here in just a minute. I want to remind you, in case you've forgotten, that the Math Center is available at many hours of the day where I am not, and the ID number to reach the Math Center, it's a Zoom meeting, is 509-574-6827. So just a reminder about that. And now let's take a look at questions that you have, if any, from 8.2. Let's see, what is it? Part 2, I believe. 8.2, part 2. Any questions you've got?
I didn't have any.
I didn't have any either. Thank you.
Okay, Greg, how about you?
No, I didn't have any.
Okay, we'll go on to section 8.3. And for that, I'm actually going to switch screens. So we're going to get rid of that one and open up this one. And go to this. Okay, and the numbers up here, the reference numbers, are just to let me know which problem I got out of the book, because I just did the graphs. I didn't write down the information that we're going to look at, and I'm going to do that as we go along here. So what we're going to be doing now is looking at pictures of graphs and determining values of X or values of Y of certain points on the graph, as well as the domain and the range in some situations. So this problem number 17, it says refer to the given graph to find each value. At 17a, it says f of -2. Now, in function notation, that is f of -2. The full story is to say, look at this graph, okay? On that graph, find a point that has an X value of -2. Let's see, this is X equals -2, so that would be right there, that point right there, okay? What is the corresponding Y value? Oh, -4. So basically for that graph, f of -2 equals -4. It's just like saying, here, complete that ordered pair, -2, comma. So you look at the graph, find an X value of -2, and find the corresponding Y value. You all right with that?
Yes.
All right, let's take a look at part B. It says f of 0. So what would f of 0 equal?
0.
Right, because X is 0 is right there, and the corresponding Y value is 0. So again, it's like we're completing that ordered pair. When X is 0, Y is 0. All right, so these first two questions, they've given us X and asked us to find Y. Now we're going to go the other way around. They're going to say, find the value of X for which f of X equals 4. F of X is just another name for what?
Y.
Y. So basically they're saying, complete the ordered pair, some unknown X, comma, 4. So back up here, where on this graph is Y equal to 4? Right there. What's the corresponding X value? 2. So the value of X for which f of X equals 4 is 2. What input gives us 4 as an output? You put 2 in, you get 4 out. You all right with that?
Yes.
So the process isn't difficult, but you've got to understand the symbols and everything, what they're asking. Okay, part D, Same question, find the value of x. So the value of x for which f of x equals -2. So where is there a point on the graph that has a y value of -2? What's the corresponding x value?
Would it be -4?
All right. Where is f of x equal to -2?
No, sorry. I was looking at the wrong.
That would be f of x equals -2. So the corresponding x value would be -1. You see that?
Yes.
Okay. All right. Let's go on to problem number 18. Here's my lovely graph. And part A, oh, and this graph is S. In fact, I'm going to go back for a minute. And here, I should have labeled this graph as F. Okay, so this graph we're going to look at next is, come on, out of the way there. There we go. So this is the graph of S. So we want to find S of -3. So the input is -3. What's the output?
Would it be 2?
Correct, because it would be this point right there. Okay. Part B, S of 3.
Would it be 4?
Yep, good job. Right there. Part C, the values of x for which S of x equals 0. So now it's asking for the values. So where on this graph does S of x equal 0?
Where x equals 0?
No. Where on the graph does S of x equal 0? In other words, y equals 0. When does y equal 0? At the x-intercepts. So what are they? Okay. S of x equals 0. Y equals 0 would actually be the x-axis. So what values of x have a value of y, a corresponding value of y that's 0? That,
-1 and 1.
that, and that. There's 3 of them. Don't all those points have a y value of 0? Remember, this is just saying.
Yes.
So basically what they're doing is they're saying complete these ordered pairs, however many of them there are. Well, there's one, there's one, there's one. Okay. Part D. Find the values of x for which S of x equals 3. Where does S of X equal 3? Isn't that Y equals 3? Wouldn't that be right along here? So what X values have a Y value of 3?
2,
And
4.
yeah. Are you getting this?
Yeah.
All we're doing is finding the other value of an ordered pair. If they give us X, find Y. They give us Y, find X. Here, they're giving us X to find Y, giving us X to find Y. Here, they're giving us Y to find X. Okay. Same question again, only now we're dealing with the function G. So G of -2 equals what? Is it hard to see the graphs?
Yeah, it's kind of hard to count. I gotta zoom in.
Okay, sorry about that. I don't know what more I can do from this end. So when X is -2, what's Y?
It's 2.
Yeah, right there. Okay. What's G of 0?
Is 2.
Yep, right there. Part C, that's what Moses did, part C. Okay, the value of X for which G of X equals 3. So what's X when Y is 3?
-1.
Right there, because Y equals 3 would be right along that poorly drawn dotted line. Okay, D, the values of X for which G of X equals -1.
Would it be 1?
What else?
-3.
Good. Okay. So when X is -3, Y is -1. When X is 1, Y is -1. These two inputs give you this same output. Questions on this before we go on? Okay. This is function H. Part A says find H of -3.
H of -3 would be 4, right?
Yep. Right there. Good. How about H of 4?
Three.
H of 4 equals 3. Good. Okay. The values of X for which H of X equals 1. My graph isn't perfect there, so you're gonna have to fudge just a little bit. I can see that it didn't quite line up.
would be 2, right?
And 0.
Yep, right there and there. So x equals 0 and 2. Okay, the value of x for which h of x equals 0.
It would be 1.
Mm-hmm. Good. Good to go on?
Yes.
Okay.
Yeah.
24. Says find the domain and range of each function. Now, when there are arrows, as we see here and here, that implies this graph continues on in that direction, and this graph continues on in that direction, okay? So we want the domain and the range, okay? And I'm going to describe them using words and then also interval notation. So the domain is the x values. So what x values are present if this graph continues on in both directions like it says? What x values? This thing continues
Are you
on.
talking about,
What?
are you talking about that straight line at the bottom or the actual graph?
Yes. I'm talking about because this actual graph, for instance, x equals 0 is right here, isn't it? X equals -1 is right there, -2, -3, -4. This thing keeps going. Even though it's going up, it's also going over. So it's going to cover all real numbers and interval notation, -infinity to +infinity. Because even though it's going up, oh wait, yeah, even though it's going up, it's still going over to the left. And even though it's going up, it's still going over to the right. So it's going to continue in both directions in terms of x forever. Do you see that?
Yes.
Now, let's talk about the range. Is -5 in the range? That would be down here. Range of the y values. Is 0 in the range? How about 2? What's the lowest range value there?
3.
Right. Does it include 3?
Yeah.
Does it include everything above 3?
Yeah, 3 and everything above.
Okay, so all real numbers greater than or equal to 3. In interval notation, you'd have a bracket of 3 going to infinity. Everybody seeing that? So your range starts at 3 and goes forever. Above, your domain goes to negative and positive infinity. So your domain's all real numbers. The range is greater than or equal to 3. Okay? What's the domain here? As those arrows are going down, they're also going over in both directions, aren't they?
So it would be all real numbers?
Yep. Good. And as interval notation, we'd have from negative infinity to positive infinity. Careful, what's the range?
Would it be all real numbers greater than or equal to -2?
Okay.
-1 or
All right, Daniela, go back to what you said. You said all real numbers greater than or equal to. It wouldn't be greater than, it would be less than or equal to, and then what Greg said, -1. The range is your y values, okay? What's the highest y value? -1. What's the lowest y value? -infinity. So it'd be all real numbers less than or equal to -1. Are you seeing that? Because right here, that y value is -1.
Yeah.
All right. Good to go on the next one? I'll take that as a yes. 28. What's the domain? Where does it start? What's the smallest domain value?
0.
Okay. And from there, where does
0.
it go?
All real numbers as 0 and above.
Okay. So all real numbers greater than or equal to 0. So bracket 0, infinity, parentheses. Okay. What's the range?
So there's only 0 on there.
Is it -infinity?
Yeah, I don't know that one.
Okay. Domain goes from smallest to largest. Range goes from smallest to largest. So what's the smallest range value there? Where does this thing go?
0.
That's the largest one. This thing goes over, but it's also going down. It's out of the way there. It's going down.
So would it be what Gregory said, -infinity?
Yes. Up to what?
0,
Right.
right?
So, right. So all real numbers, oops, less than or equal to 0, and interval notation -infinity up to 0. Because your x's are over here, your y's are over here. Okay, this is domain, this is range. This is domain, this is range. So your domain starts at 0 and goes to infinity. Your range starts at -infinity and goes up to 0. And I'm having too much fun just scribbling all over the place. You okay with that?
Yeah.
All right. New drawing, more questions. Find, oh, and this is the graph of the g function. Find g of 1. G of 1.
1 would be 1.
Maybe it's kind of hard to see. Let me see here. So what's G of 1?
Wouldn't it be 1?
No. Complete this ordered pair. 1 comma what? When X is 1, what's Y?
2,
There you go.
right?
Okay. Complete this ordered pair. -4 comma what?
-4.
Yep. Because this right there is -4, -4. So that when the input's -4, the output is -4. Find the values of X for which G of X equals 4. Isn't G of X equals 4 right there?
So would it be -2 and +2?
Yep. Again, all we're doing is I'm saying, look at the graph. When X is this, what's Y? When Y is this, what's X? So this question is saying, what are the X values when Y is 4? Well, right there and right there, the X values are -2 and 2. This question is saying, what's the Y value when X is 1? So when X is 1, oh, Y is 2. Okay. What's the domain? Keep in mind, these things are going down, but they're going over, down, they're going over.
All real negative numbers and all real positive numbers.
And also 0, which is neither negative or positive. So it'd be all real numbers, okay, which would be -infinity to +infinity, okay? What's the range? That's where the deer and the antelope play. You know, home on the range, where the deer and the antelope, whatever, okay. Maybe you don't even know that, so. Tell you what. Is Y equals 7 on this graph? Is there a Y value of 7? Is there any Y values up there at 7?
No,
How about
No.
6?
no,
5?
no,
4?
yes,
3?
Yes.
-10 billion?
Yeah.
So what's the range?
All real numbers 3 and below.
So all real numbers less than or equal to, actually, you said 3 and below, it should be 4. Because maybe you did say 4, I don't remember. And then interval notation would be that. Again, what X values are there? Well, as this thing goes down, it goes over, goes down, it goes over. So it's going to cover all the X values, but the range goes from negative infinity up to, but it stops at 4. There isn't any range value that's higher than a 4. It stops right there. There's your highest range values. Okay. Y equals 5, not on the graph. All right. Daniela, you getting this?
Yeah, I think so.
Greg?
Yeah, I'm catching on.
Okay. Let's see. That's all the examples I've got, but let me give you some more examples here. All the ones that I wrote ahead of time. Let me ask you this. Is that the graph of a function? In other words, does each x have just one y?
No.
Right. And for example, let's take these two x values. X is 6 and y is 4. Here x is 6 and y is 8. So the same x value has two different y values, doesn't it? So it's not a function. In fact, we could use what's called the vertical line test. If I can draw a vertical line through the graph and it cuts through the graph, oops, I want to switch to my different thing here. It cuts through the graph more than once, then it's not a function because you've got one x value, 6, going to two different y values, 4 and 8. So not a function. Does that make sense?
Yeah.
Okay. How about, let's see here. Is that a function?
No.
Why not? Is there an x going to more than one y? The filled in circle means it's included and the open circle means that value is not included. So does it fail the vertical line test? Is there a vertical line I could draw that would go through more than one point on the graph?
No.
No.
So is it a function?
Yes.
Yeah.
Yeah.
Okay, now, what if I did this? What if I filled that point in? Now is it a function?
No.
No.
Correct. It's not, because now you've got x is -2, goes to -2 and goes to 1. So it's not a function. Good. Okay, here, come on. Let's see. We're gonna do that. And how about, let's see. How about that? Is that a function?
No, right?
Correct, it's not. X, -4, Y, all kinds of stuff. So you've got one input going to an infinite number of outputs. So not a function, not a function. That's supposed to be an A. All right. How about this? Function or not?
Yeah, it's a
Yes.
function.
Good. Function or not?
No.
No, 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 no. That's a lot of no. Is that a function?
Yes.
Good. I'm waiting for that screen to disappear. Let's see here. Is that a function?
Yes.
Good. All right. So that ends